All right, 12 says 2 identical arrows, one with twice the speed of the other, are fired into a hay bale. Assuming the hay exerts a constant stopping force on the arrows, how much farther will the faster arrow penetrate into the hay than the slower one? So, here is a hay bale. Hay bale. Here is an arrow. Arrow number 1 is going to be traveling at a velocity of v. Okay? So, for arrow number 1, the kinetic energy initially is going to be 1/2 mv squared, right? What's the final kinetic energy going to be? 0. Do we need to worry about GPE at all here? No. So our change in total energy here, in other words, the work done by the hay, is negative 1/2 mv squared, right? Good? All right. Now, arrow number 2 is traveling at a velocity of 2v. Oops, arrow number 2. Number 2. Number 1. So arrow number 2 is traveling at a velocity of 2v, right? So what's the kinetic energy for arrow number 2 going to be? It's going to be, the kinetic energy initially is going to be 1/2 mass times 2v squared. So the 2 is going to get squared, and you actually get 4 times 1/2 mv squared, right? So what I'm trying to get at here is it's going to have 4 times as much kinetic energy, right? That means to stop it, you got to do 4 times as much work. So if work is force times displacement, and your force is fixed, then 4 times the work is going to take 4 times the displacement. Does that make sense?
Yeah.
Everybody? So applying this to real life, nobody cares about arrows. But driving, if you're driving twice as fast, it takes you 4 times the distance to stop. Right? Because the brakes, the force exerted by your brakes is constant. If you're going twice as fast, because of this squared, you've got 4 times as much energy. Okay? All right. Questions on that? That's really more algebra than anything. So, all right. So that's 12. Are we good? No?
Oh, I have a question on that.
Yeah. What do you got?